Hello, viewers at home. Once again, I'm back again. I still remain your mathematics teacher, Mr. Adesanya Ademola. Today, by the grace of God, we still want to continue with our topic, mensuration. Don't forget that the class we are dealing with is SS1 subtopics. Today, we are looking at perimeter of a circle and segment. It is expected that at the end of this lesson, students should be able to recall and use formula to calculate perimeter of a circle and segment. Students are also expected to solve problems on perimeter of circles and segments. Now, let's go back to the business of the day. Perimeter of a circle and segment. But I would like to start with perimeter of a circle. Perimeter of a circle is the distance along the circumference of a circle. Dividing the circumference with the diameter of the same circle, the result is pi. What do we mean? It shows that when you divide the circumference of a circle with the diameter, the result will give you pi. This is illustrated below. Circumference over diameter is equals to pi. Circumference over diameter, where your diameter is d, is equals to pi. So when you cross multiply, we will have circumference is equals to pi d. So the formula for finding the circumference is pi d. Better still, your diameter is 2 radius. So circumference become 2 pi r. So at any point in time, perimeter of a circle is equals to circumference of a circle. And circumference of a circle is equals to 2 pi r. Now, let's look at perimeter of a segment. Don't forget, in our previous class, I told us that we can have a minor segment, we can also have a major segment. And so when a circle is divided into two unequal parts by a chord, you have minor segment, you also have a major segment. Now, what is a segment? A segment is bounded by an arc and a chord. We have a major segment and a minor segment. Now let's consider the circle below. In this circle, we have major segment, we have a minor segment. The major segment is divided, the major segment is separated from the minor segment by a straight line that divides that circle into two unequal parts, and that straight line is called a chord. Now, if you look at the diagram very well, either you are considering the major segment or you are considering the minor segment, you will agree with me that the perimeter of the segment is equals to length of an arc plus chord length. And the length of an arc from our previous lesson, the formula for finding the length of an arc is theta over 360 times 2 pi r, while the formula for finding the length of the chord is 2r sine theta over 2. So looking at the diagram we have here, this is a major segment. The straight line we have there, that is the chord length, which connotes 2r sine theta over 2, while the the remaining circumference that you have there is called the length of an arc, which is theta over 360 times 2 pi r. So the perimeter of a segment is the addition of the length of an arc and the chord length. So invariably we can now say that the perimeter of a segment is equal to theta over 360 times 2 pi r plus 2r sine theta over 2. So let's look at the first example. Find the perimeter of minor segment whose chord subtends an angle 60 degrees at the center with radius 6 cm, taking pi to be equal to 222 over 7. So solution. Quickly, from the example 1, there are some information we have there. the value of theta is 60 degree, the value of radius is 6 centimeter, while the value of pi is 22 over 7. So we write out the formula for finding the perimeter of the segment. And the perimeter of the segment is theta over 360 times 2 pi r plus 2r sine theta over 2. So we now substitute into that formula. The perimeter of a segment is equals to 60 degree over 360 times 2 pi times 2 times 2 over 7 times 6 plus 2 times 6 times sine 60 degree over 2, which will give us, when you divide 60 by 360, you're going to have 1 over 6. Then multiply by 22 times 20, so that will give you 44 times 6 over 7 plus 2 times 6, that is 12 times sine 30 degree, which will be equals to um, 44 over 7 plus 12 times 1 over 2. And finally, you are going to have 44 over 7 plus 6, which invariably will give us 44 over 7 plus 6 over 1. And when you find the LCM, you are going to get 44 plus 7 times 6 over 7, which is 44 plus 42 over 7. That will give us 86 divided by 7. And finally, that will be 12 whole number 2 over 7 centimeter. We go to example 2. If the chord of length 6 centimeter is from the center of a circle with radius of 10 centimeter and the angle subtended at the center is 60 degree, calculate the perimeter of the segment. Now, in the first example, we are asked to calculate the perimeter of segment. In the second example, we are also asked to calculate the perimeter of a segment. And so, but there is a difference between the first example and the second example. In the first example, we are given the angle, which is 60 degree at the center, but we are not given the length of a chord. And so in the example 2, we are given the length of a chord, which is 6 centimeter from the center of the circle with the radius of 10 centimeter. However, we are not given the length of chord AB. Now, we are still going to adopt that formula, which says perimeter of a segment is theta over 360 times 2 pi r plus 2 r sine theta over 2. Now, if you look at the diagram, we have two right angle triangle. The first one is AMO, while the second one is OMB. From triangle OMB, we are going to use Pythagoras rule to find MB. Don't forget that MB is the midpoint of AB. So once we are able to get our MB, automatically we will only multiply by 2 to get our length AB, which is the chord. Now, when we use Pythagoras rule, then that tells you that the longest side, or the side that faces the right angle triangle, which is 10, you square it, and that will be equals to c square plus mb square. So when you collect the line, when you rearrange, our mb will be equals to square root of 10 square minus 6 square, which invariably will be square root 100 minus 36, and that will give us square root of 64, which is 8 centimeter. So our mb is 8 centimeter, therefore AB will be 2 multiplied by mb. Now that we have known our mb to be 8, so 2 multiplied by 8 will give us 16 centimeter. But don't forget that the perimeter of a segment is equals to length of an arc plus length of a chord. Now that we have known the length of a chord, there is no need for us to make use of the previous formula for the length of a chord. We will just substitute directly into that. but the length of an arc is still theta over 360 times 2 pi r. So perimeter of a segment will be theta over 360 times 2 pi r plus length of a curve, which is 16 centimeter. So when you substitute, you have 60 degree over 360 degree times 2 times 22 over 7 times 10 plus 16 centimeter, which will give us 1 over 6 times 440 over 7 plus 16 centimeter, and that will give us 220 over 21 plus 16 centimeter. When you divide 220 by 21, you are going to have 10.47. You now add 16 centimeter to it, and that will give us 26.47 centimeter. Therefore, perimeter of the segment is 26.47 centimeter. Now, today I'm not going to give you an activity, but I'm giving you an assignment, and this is the assignment. Calculate the perimeter of a segment whose chord subtends an angle 45 degree at the center with radius 7 centimeter, taking pi to be 22 over 7. So that is where we are going to stop today. Please make sure you do your assignment, and by the time we meet next, we will look at the solution to the assignment, and from there we will go into the next subtopic, which is going to be area of a sector. And till then, I still remain your mathematics teacher. Stay safe, stay blessed. Bye bye.